You have heard the bloop. Almost everyone has. 1997. A sound crossed the Pacific Ocean. Two sensors 3,000 miles apart both caught it, and it was louder than any animal alive can call. That is where the story usually stops. A monster, a recording, and no ending. Two things got left out. The clip you have heard is sped up. At its real speed, the bloop sits below what your ears can reach. And it has had an answer for years. It was ice. At a NOAA lab in Oregon, an acoustician named Christopher Fox ruled out a ship, an earthquake, a weapons test. Each of those has a signature he already knew. He had nothing left to compare it against. Those sensors belonged to a listening array. It had been in the water barely a year. 7 sounds, each one recorded, logged, and left without a name. This codex opens on a question about evidence. A fossil waits in a drawer. We can go back and measure it again next year. A sound is gone the moment it stops. What survives is a recording, a date, and a position, if anyone was lucky enough to get one. Everything after that is a guess somebody has to defend. That sets the standard for this entry. The sound was recorded by an instrument we can name. The recording still exists, and somebody closed the case, or failed, and we can say exactly why. 6 of these have answers now, published, checkable, and duller than the story they replaced. Not one turned out to be an unclassified animal. The 7th has no answer at all. Start with something ordinary. Right now, hydrophones are recording in the Pacific, the Atlantic, and the Southern Ocean, and much of that audio is public. You can sit at a desk and listen to the sea floor. That is a very recent thing to be able to do. The ocean makes it possible because of a layer roughly a kilometer down. Cold water and pressure bend sound back toward the middle of that layer instead of letting it escape. A noise that enters it stops spreading out. It starts going the distance instead. It is called the SOFAR channel, and it is why one event near Antarctica can be heard off the coast of South America. The second rule matters more, and almost nobody explains it. To say where a sound came from, you need at least 3 instruments to hear it. Sound reaches each one at a slightly different moment. Those differences give you 3 arcs, and the arcs cross in one place. 2 instruments give you a line. 1 gives you a rough direction, and no way to trust it. Hold on to that number, 3. It decides which of these sounds could ever be solved, and one of them fails the test permanently. For most of the 20th century, the ears in the deep ocean belonged to navies, and mostly to the United States Navy, listening for Soviet submarines. Civilian scientists did not get access until the Cold War ended. In 1996, NOAA put its own autonomous hydrophone array into the equatorial Pacific. What happened next has been told as a run of monsters. It is better understood as a new instrument switching on. March 1st, 1999. The hydrophones recorded a wailing moan that ran for 2 minutes and 43 seconds, loud enough to cross the entire equatorial Pacific array. NOAA logged it as Julia. That name is most of the reason the internet knows it. A sound labeled with a woman's name gets heard as a woman, and once people hear a voice, they stop looking for a mechanism. Arrival times traced it to a stretch of coast between the Bransfield Strait and Cape Adair. Cape Adair turns up again and again in these records, a known source of what the literature calls cryogenic signals, sounds made by ice. An iceberg the size of a city does not float free everywhere it goes. Most of it is underwater, and that submerged bulk is the keel. When the keel touches bottom, the whole mass shudders, sticks, and slips again. The sea floor becomes the body of an instrument. Talon Daye and colleagues documented this entire class of signal in 2006, recording icebergs parked and drifting across the southern Indian and Pacific Oceans. Grounding bergs have a sound, and it is now a documented one. Julia fits inside it. The voice was a keel. 2.5 minutes of a mountain of ice settling onto the seabed. And it was not the only one on the tape. May 19th, 1997. A sound that took about 7 minutes to slide down in frequency and fade out. Something immense, grinding to a halt. That descent is where the name came from, and it is what convinced people it was alive. It falls the way a call falls, over a stretch long enough to feel deliberate. The attribution is friction, a large iceberg running aground and losing speed against the seabed. The slide in pitch is not a voice dropping, it is something heavy losing speed, and the sound going down with it. Ice is not one sound, it is a vocabulary. A glacier shedding a berg starts with high cracking as the ice fractures, drops into a low roar as the block detaches and falls, then hits the water. Air, trapped for thousands of years, comes out of it all at once, fizzing. Grounding sounds nothing like calving, and calving sounds nothing like ice, simply cracking under its own weight. Learning that vocabulary is a discipline now, with a name, cryoacoustics. Nobody decoded slow down like a cipher. Researchers built the library first, then held the old tape up against it. The sound never changed. The reference material did. March 5th, 1997. A rising, rhythmic signal that people describe the same way every time. A locomotive coming toward you. NOAA logged it as train. It is the most mechanical-sounding entry in the catalog, and it is the one most often dragged into videos about lost submarines. A rhythm sounds manufactured, and manufactured implies somebody down there making it. The attribution points to the Ross Sea, near Cape Sodare, a very large iceberg grounded there, with the rhythm coming from stick and slip as it moves. Which iceberg? Nobody can say. It was never identified. Ice against rock does not scrape smoothly. It grabs, holds, builds strain, releases, then it grabs again. That cycle has a frequency, and the frequency is set by mass and friction. Nothing is choosing it. Run it beneath a berg the size of a city, and you get a rhythm regular enough to sound like an engine. One question comes up about train constantly, in the comments of every video that covers it. No video has ever answered it. Does this sound like the 52 Hz whale? It is a reasonable thing to ask. Two strange patterns, both unexplained at the time, both pulled off the same equipment. People join them together because nobody ever told them not to. Keep hold of that. It matters at the end. Upsweep is the one everybody leaves open. It was first identified in August 1991, when the Pacific Marine Environmental Laboratory started listening. Hold on to that date. Upsweep is a train of upward sweeping tones. It peaks twice a year, in spring and autumn. It has been running, on and off, for the whole time we have been able to hear it, which makes it the only one here that is not finished. It is happening now. The source sits at roughly 54 degrees south, 140 degrees west, an empty stretch of the South Pacific with submarine volcanic activity. The attribution is volcanic. Seawater meeting molten rock, over and over, at a scale that turns a geological process into a repeating note. Since 1991, it has been getting quieter, and it is still there. Almost every video on this subject still reports Upsweep as unidentified. That was true for a long time, and it stopped being true quietly, in the literature, without a headline. The timing is the whole point. Upsweep was not first heard because the ocean started doing something new in 1991. It was first heard because 1991 is when anyone was in a position to hear it. Then there is the whistle, July 7th, 1997. It resembles the volcanic signals recorded around the Mariana Arc, which gives it a probable source of the same kind. Here is what makes it permanent. The whistle was caught on one hydrophone. 1. Locating anything takes 3. The whistle therefore has a probable cause and no address, and it always will. Not because the sound is strange, and not because the science failed. On that day, in that part of the Pacific, only one machine was listening. Which brings us back to the loud one. The bloop is the most famous unidentified sound ever recorded, and its answer is the least satisfying thing in this video. That is exactly why it belongs here. 1997. Loud enough to register on sensors up to about 3,000 miles apart. The profile looked biological, and that is the detail that started everything. Not the volume, the shape. NOAA's acoustics program attributes it to a large cryoseism, an icequake, ice cracking under its own weight. The reason that attribution stuck is not an argument. It is a match. NOAA hydrophones in the Scotia Sea recorded icequakes directly and used them to track iceberg A-53A acoustically as it broke apart near South Georgia in early 2008. The signatures line up with the 1997 trace. The internet is far more certain about the bloop than Christopher Fox ever was. He told CNN in 2001 he thought it was ice calving. He had also, at other times, leaned towards something biological. The source, he noted, would have to be far more powerful than any animal on Earth. The man closest to the data held 2 positions across a decade. That is what working without a reference library looks like. The next one was hiding behind a joke. In the 1960s, submarine crews in the Southern Ocean kept hearing a repetitive quacking. They named it after the obvious thing, the bioduck. It is a low-pulse train, evenly spaced. It ran for decades. Crews heard it year after year, right across the Antarctic, and their whole job was knowing what they were hearing. It sounded too regular, too mechanical. So the first guesses were all man-made, that it was the submarines themselves. Fish were suggested. So were UFOs. The map made no sense either. It turned up in the eastern Weddell Sea. It turned up off Western Australia. Same season, both places. That leaves 2 options. One kind of animal spread impossibly wide, or one population split, with some of it staying and some of it moving. The answer came in 2014. Denise Risch and colleagues published it in Biology Letters. They put recording tags on Antarctic minke whales. Then they caught the animals making the sound. Notice the mechanism. It is the same one every time. Nobody solved this by thinking harder about the recording. That tape sat there for 50 years and never gave anything up. Somebody put an instrument on the animal and watched it happen. 6 down, 1 left. In 1989, the Woods Hole Oceanographic Institution picked up a whale call at 52 Hz. That number is the whole problem. Blue whales and fin whales call much lower. No known whale uses 52 Hz as its signature. William Watkins and colleagues at Woods Hole tracked it for 12 years and published the record in 2004. The same call, the same frequency, season after season, on a track matching no known population's migration. Their finding was carefully worded, 1 call with those characteristics, and 1 source, each season. It got a nickname, and the nickname did real damage: the loneliest whale in the world. Look at what the data actually supports. The call is unusual, not inaudible. Other whales can hear it perfectly well. It simply sounds wrong to them, the way an accent does. And the animal has been tracked for over 30 years. It migrates, it feeds, it has survived. That is not what a dying, isolated animal looks like. The sad story was ours, not its. What is documented is narrower and stranger. A real animal, calling at the wrong frequency, recorded for 37 years. And nobody has ever seen it. Every other sound here closed the same way. Somebody eventually got eyes or a tag on the event while it was happening. The berg, the minke, the volcano. That has never happened with this one. And that question about train comes back here. The evidence never supports it. Train is ice. This is an animal. Their only real connection is that we heard both on the same equipment. Line the answers up and the deep sea stops looking haunted. Julia, slow down, train, ice. The bloop, ice. Upsweep and the whistle, volcanoes. The bioduck, a minke whale. Ice, rock, and animals. That is the entire monster canon. Look at the dates instead, because that is the part that has been sitting in the open for 28 years. Train, March 1997. Slow down, May 1997. The whistle, July 1997. The bloop, the same year. NOAA's Equatorial Pacific Hydrophone Array had been in the water since 1996. Fox, Matsumoto, and Lau published the deployment and what it was built to monitor in 2001. The same Christopher Fox from the Oregon lab. 4 monsters in 1 year. Not because 1997 was a strange year in the ocean, because 1997 was the first full year anyone was listening this well, across that much water, with nobody yet holding a catalog of what the ocean normally sounds like. That is why the answers took so long, and it is why every one of them arrived the same way. A 53A breaking apart in 2008, tags on minke whales in 2013. Each case closed at the moment somebody finally witnessed the event and could hold it against the tape. The sounds never changed. The observers caught up. This Codex entry ends where it opened, in an Oregon lab in 1997. Christopher Fox ruled out a ship, an earthquake, and a weapons test, and he was right to rule out all 3. He simply had nothing left to compare it against. The array that heard it had been in the water barely a year, and the sea had been making that sound for as long as there has been ice. None of this is a list of mysteries. It is a record of how far a new instrument runs ahead of the people holding it, and how long they take to catch up. We did not discover 7 monsters. We built an ear, then spent 30 years learning to hear. One of them is still open. A whale we have heard every year since 1989 and never once seen. Hearing something you cannot see is one kind of blindness. There is a worse one. For decades, ships went looking for the giant squid with everything we had. Floodlights, high-definition cameras, crude submersibles, thousands of dives over most of a century. The animal was not rare. It was not hiding. The problem was the search. A world that is black and nearly silent does not forgive floodlights and engine noise. Every expedition announced itself on the way down. They arrived loudly enough to empty the room before they got to it. In 2019, in the Gulf of Mexico, somebody tried the opposite of everything on that list. What else have we missed, only because of the way we went looking?